Good afternoon, everybody. This is Steve Fletcher with a trumpet for my people. I want to share a piece of information that was sent to me this afternoon, passing this information on so everybody knows what is happening. Microsoft patent 060606, body interfaced digital currency. This is an actual patent. This actual patent is in the link. It is real. Here is the link. I will leave the information for you to this article, the link to the patent. Unbelievable, in-your-face evil, reality here now. Microsoft patent 060606, body interface digital currency, mark of the beast. The full patent ID is W02020060606. Microsoft 3/26/2020, in conjunction with their public ad featuring infamous Satanist Marina Abramovich. Human body activity associated with a task provided to a user may be used in a mining process of a cryptocurrency system. A server may provide a task to a device of a user which is communicatively coupled to the server. A sensor communicatively coupled to or comprised in the device of the user may sense body activity of the user. Body activity data may be generated based on the sensed body activity of the user. The cryptocurrency system, communicatively coupled to the device of the user, may verify if the body activity data satisfies one or more conditions set by the cryptocurrency system, and award cryptocurrency to the user whose body activity data is verified. Monitors thoughts, energy, actions, feelings, body movements, cannot buy, sell, travel, work, or exist without it implanted in the human body. Now let's check out this link that was also sent. Okay, I opened up the link with the article, which I will include for you, the article and the link to this that is written inside of the article, W02020060606, patent for cryptocurrency system using body activity data. Here is the information, how it works. This was published on March 26, 2020. Applicants, Microsoft Technology Licensing. Patent number 666, cryptocurrency system using body activity data. I just wanted to pass this information on, make sure everybody knows where this is all headed. Oh, Jesus. Come, Lord Jesus. We pray, Lord God, that you will come soon for your church, because we did not expect to see all of this. Thank you, Lord. We know that you are going to be here soon for us. I pray you're all blessed today. This is Steve Fletcher with a trumpet for my people, the sign of his coming revealed.
Carter City is stunned by the sudden rollout of Rook Unlimited's most fantastic device ever. The Smart Mark. Throw your other devices away, because the Smart Mark is more than just a phone. It's part of you.
You know, it is creepy. Like I'm filming you with my eye. It's supposed to be, pretty human part of your body.
You took me as a human and added something to it, gave me more function, gave me something I didn't have before. That's what really made me inspired about transhumanism as a goal. You're allowed the option. We can do whatever we want.
It's a very natural impulse. It's people want to be able to do things they can't now do. The thought is that sometimes it's much easier to do things by something which is attached or implanted in your body than to do something using, a tool.
We're evolving to become something else. So for me, being human is something temporary, and that we shouldn't be afraid to change.
Transhumanism involves the transformation of our biological brain into an electronic vehicle that will have perpetual existence and limitless capabilities.
I think transhumanism is going to be responsible for some of the very first trillionaires.
So each one of these, because it's still a vacuum, really not cold on the outside, is extremely cold inside.
It amazes me that this has not caught on more. I just constantly am thinking, why aren't tens of thousands of people doing it?
It's amazing to me, and probably to you, that they would rather die than think about coming back into a world that's really different.
Check this out, guys. I'm Leanne from Red Pill Crew. I've had my vaccine. Today. Shine it there, nearer to that dot. Oh, jeez, look at that. I've had my vaccine in my hand. Oh my God. What have they put in that vaccine?
All right, so let me know how satanic you think this is. I'm on Moderna's website. You go to mRNA technology, go to intellectual property, scroll down, and then it says to check out our patents, click here. You click there, click any one, but the first one, and then you search at the top. Where is it now, boy? Luciferase, okay? And these are ingredients in the vaccine. Luciferase. Lucifer, isn't that kind of like biblically a bit, hold on a sec here. Let's type this in and let's check. What is luciferase? It's a generic term for the class of oxidative enzymes that produce bioluminescence. Is this the thing they're going to use so that they shine something on your wrist? And if you've got the vax, you'll light up a certain color. This is, and what's it with the term luciferase? Couldn't it have been like light A's? Couldn't it have been something other than Lucifer, man? But if you dig into luciferase, it seems like this is what has been biblically referred to as the mark of the old beast there. And very, very satanic to inject someone with something like this. But anyway, check out Moderna's website. Would you believe that? They tell you right there, man. Luciferase.
이게 제가 버튼을 누르면 레이저가 일단은 뇌로 이제 자극이 들어갑니다. 그렇게 되면 이제 로테이팅을 하기 시작할 겁니다. 예, 지금 제 레이저를 넣겠습니다.
보이시죠? 파란 불빛.
그러면 이제 로테이팅을 하고요.
진짜.
이제 시작하면
Desde la quinta columna, queremos concienciar a toda la población a que esté alerta al cambio del alumbrado público por focos de luz azulada o ultravioleta. Usarán explicaciones peregrinas para su implementación. Os dirán que es para la concienciación de la sociedad frente a determinadas enfermedades, supuestas aplicaciones germicidas o uso de ese alumbrado por bajo gasto energético. Pero la verdadera razón es infinitamente más oscura. Gran parte de la sociedad ya conoce sobradamente cuál es la naturaleza del material interfaz, inoculado bajo el engaño a toda la población. Este material es interactuante con la radiación emitida por esos focos de luz azulada ultravioleta. Por una parte, cataliza el estrés oxidativo en la superficie de este material, lo cual se traduce en mayor cáncer, neurodegeneración, pulmón COVID, entre otras. Además, habilita una subbanda en este material para aplicaciones ópticas y optoelectrónicas. La radiación ultravioleta también degrada las microhojas de grafeno en nanopartículas, con capacidad para atravesar la barrera cerebral hematoencefálica. Es decir, comunicación intracorporal con la nube y la inteligencia artificial. Estamos hablando de neuromodulación y neuroestimulación, además de monitoreo neuronal. De la capacidad de introducir instrucciones a nivel neuronal usando estos focos de luz azulada ultravioleta. Igualmente, anunciamos que estamos sometiendo muestras de la vacuna Comirnaty Pfizer a la estimulación con este tipo de luz. Pronto, presentaremos los resultados obtenidos para el conocimiento vital de todos. Nuestros enemigos juegan con la ignorancia de la mayor parte de la sociedad.
Just would like to highlight what you said about the European Chips Act, because it's a very important step to create the physical brain for digitalization and to have it located to a certain extent in Europe.
백신을 맞으면 블루투스가 생겨서 트랜스휴먼이 된다, 뭐 이런 얘기죠. 아마 아시는 분들 다 아실 텐데, 이게 뭐 공원이나 도시 내에서는 작용 범위가 넓은지 잘 안 잡혀요. 그러니까 전 백신 안 맞았는데 옆에 멀리 떨어져서 아줌마 아저씨 있으면은 뭐 마치 내가 뭐 블루투스가 된 것처럼 그렇게 뜬단 말이야. 그래서 그런 문제가 있기 때문에 자연숲에서 이렇게 실험을 한 것 같은데, 그래서 나노기술, 뭐 그래핀 등의 요소가 있다. 그래서 산화 그래핀이 있다는 얘기가 나오죠. 그리고 몸속의 수소 반응해서 블루투스 앱 자기 조립돼서 그 탄소 나노튜브 방식으로 전자기기가 된다라는 얘기가 됩니다. 그리고 이런 주소가 생기고 고주파 같은 거에 의해서 자기 충전이 일어난다. 또 어드레스 센스레스 하면 그 주소 정기적 변경된다. 공동묘지에서 이렇게 사망한 사람들에게 이런 게 잡힌다. 아마 이거 맞은 분들 다 잡힐 겁니다. 1차만 맞아도 잡힐 텐데, 그러니까 맞은 사람들이 이거 인정 안 하려고 하죠. 이게 좀 문제고, 빨리 인정을 해야 이게 어떻게 처리가 되는데, 이렇게 심각해도 지금 뭐 백신 패스가 끝났고, 결국에는 뭐 인체도 90일 정도가 지나면은 그 모든 세포가 교체가 됩니다. 문제는 그렇게 교체가 돼도 그래핀 같은 중금속은 안 빠지니까 이런 거를 뭐 그 중금속 빼는 채소, 뭐 약화시키는 채소 같은 걸로 빨리 좀 해독을 해야겠죠. 안 그러면은 그 맨날 핸드폰 5G 쓰잖아. 5G 쓰면서 계속 이렇게 전자파 피폭되면서 그 수명이 줄어든다니까. 제가 봤을 때 요새 사람들이 예민한데 이거 전자파 피폭 계속 당해서 그래. 자기는 모르는데 계속 뭔가 누가 공격하는 것 같으니까. 그러니까 자기도 날이 서는 거야. 도대체 뭡니까? 뭐 중금속 빼는 거나 뭐 그런 거 해서 뭐 그래핀을 빼야겠죠. 몸에 있는 고여있는 그래핀 중금속들을 빼야겠죠. 아마 이런 채소가 많을 거야. 그거를 주기적으로 섭취를 해라. 그 크기가 나노니까, 나노라는 거는 어떤 특정한 중금속 배출 영양소를 나노 단위로 섭취를 해줘야, 어떤 걸 먹으면 그게 나노 단위로 작용을 해가지고 그게 나오는 거 아니야. 몸에서 배출을 시키는데 도움이 될 거 아니에요. 좀 그런 것 같습니다.
자, 지금 완전 시골에 왔습니다. 사람이 아무도 없는. 자, 저희는 두 명 다 비접종자이고 안 뜹니다. 저희 지금 하나도 안 뜹니다. 블루투스 앱에 지금 한 개도 안 떠 있죠 지금. 저기 무슨 건물 카페 같은 게 있어요. 카페. 어째 사람 한 명
떴어요 지금.
하나 뜹니다. 하나 떴죠 지금.
한 명이 있습니다.
지금 한 명 더 떴죠. 지금 할머니 한 분이랑 카페 저기 두 명 여기 두 분이 계십니다. 지금 두 개가 떴어요. 두 개가 보이시죠? 지금 여기 사람이 한 명. 지금 총 하나가 더 떴는데 아마 저 카페 요 카페 안에 주인이 지금 계십니다. 3명. 그리고 없죠 지금 주변에. 지금 딱 3개가 떴습니다 지금. 자 그리고 차를 돌려볼게요.
4개. 요거는 하나는 기니까 장비가 떴네.
블루투스 하나는 블루투스 장비입니다 지금.
두 개.
지금 사람이 지금 여기
화면 하나. 조금씩 멀어지니까 그런 것 같아요.
우리가 멀어져서 그렇고. 그러면 우리가
지금 눈에 보이는 아주머니가 한 분 계신데 거기는 잡혀요 지금.
지금 여기 아주머니가 지금 지나가고 계시죠? 네. 그리고 여기 한 분 더 계십니다. 요만. 저기 한 분 계시고.
오, 갑자기 사람이 늘어나니까 이게 늘어납니다.
네, 카페를 지나가고 있습니다. 이 카페 안에 사람이 있어요. 자, 여기를 지나가 보겠습니다. 자, 여기 지나갑니다. 지금 저 카페 안에 손님이 잡히고 우리가 멀어지니까 지금 하나씩 사라지죠? 지금 사라졌습니다. 2개. 자, 지금 도로로 지금 이렇게 하나 사라졌고.
네, 다 사라졌어요.
지금 다 사라졌습니다. 지금 사람들 지나가니까
인적이 없으니까 완전히.
네, 지금 여기까지입니다. 지금 여기 인적이 없는 지금 캠핑장입니다. 보면은 지금 하나도 없죠 지금 블루투스 기기가. 여기 캠핑장에 주인이 한 명 계시다고 합니다. 가보죠 한번. 지금 아무도 없어요. 하나도 안 잡히고.
천천히 가고 있을 테니까.
반사돼가지고 잘 안.
천천히 가고 있을 테니까 경관을 한번 찍어봐요. 나오면
오! 2개 떴는데? 저기 2명 있나 본데? 2개 떴어요? 뭐야? 이렇게 많이 떠. 5개. 캠핑장에 사람들이 있나 본데?
EM이라는 거는 장비고.
하나 떴네.
갑자기 왜 이렇게 많이 떴다가 줄어들다 이러지?
지금 한 명. 일단 사라지지 않는 건 하나. 이 블루투스 넘버는 계속 바뀐다고 하죠? 접종자들도 2개 떴네.
사람이 있을 수도 있어 이게. 누나가 몰라서 그렇고.
옆에도 있으니까.
그러니까. 파로 찍힌 거 보니까 몇십 미터
사라졌고 3개.
오, 갑자기 막 몇 개가 뜨네.
4개. 지금 4개 떴어. 4명 있다는 얘기인데.
그러면 사람이 있는지 한번 확인해 볼까요, 여기? 네. 사람 목소리 들리네.
저기 있네. 저기 한 명. 저기 한 분 계시고요. 저 일단.
그리고 가라는 게 있고, 요거는 장비고 가라고 잡히는 건 NA로 잡히는 게 몇 개가 현재 나와요.
사람 목소리가 들려요.
그리고 요
체크. 저기 애기는 맞았을 리가 없는데.
가족이 있는 것 같은데.
가족이 있어. 저기 지금 캠핑 하고 있는 사람이 있는 것 같아요. 저 안에. 지금 그래서 이렇게 잡혔습니다. 2개.
Todo empezó cuando esperábamos comer en un restaurante en Chorrillos. Éramos los únicos clientes y vimos que había solo una señal Bluetooth. Otro día estuvimos en una cafetería muy concurrida del distrito de Miraflores y ¡wow! ¡Qué cantidad de señales Bluetooth! Nos habían llegado videos de denuncias de este fenómeno en otros países, pero somos de los escépticos que no creen todo lo que aparece en redes sociales. Así que buscamos en internet varios informes y encontramos la confirmación de que sí se puede usar el cuerpo humano para emitir estas señales, algo que nos animó a seguir con este reporte. Para esta investigación periodística solo usamos el smartphone de la productora, que es un Xiaomi Redmi de gama media, que tiene un buen buscador de Bluetooth. Aquí las señales extrañas son de color plomo y las de color verde son las de teléfonos celulares y otros equipos reconocidos. Descubrimos que esas señales extrañas son direcciones MAC, que se usan para identificar a un equipo en una red. Una dirección MAC es única en el mundo y puede ser emitida desde teléfonos celulares, televisores y equipos de sonido. MAC significa control de acceso a los medios y es un identificador muy eficaz.
Y para hacer nosotros la prueba entramos a la opción Bluetooth, activamos, inmediatamente empieza a buscar el dispositivo, los dispositivos poco usados. Y como pueden apreciar sale el número 1. Al desglosar observamos que es un televisor LG.
Que es el que vimos acá. Que es el mismo número, ¿ves?
Es el mismo número, en efecto, sí es el mismo número.
Fuimos al Parque Kennedy del distrito de Miraflores y vean la cantidad de direcciones MAC no reconocidas. Aprovechamos para ver la presentación de un libro y saltaron muchas de estas señales aparte de la laptop y los teléfonos celulares. No queríamos quedarnos con esa duda y nos preguntamos, ¿podrá pasar lo mismo donde no hay muchas personas? Para eso, otro día fuimos a un parque vacío del distrito de Comas en busca de direcciones MAC sin especificar. Sí, de esas de color plomo. Y encontramos que había 2 señales inespecíficas y los 2 restantes eran equipos electrónicos. La razón fue que había un grupo pequeño escuchando música a 15 metros más o menos. Seguro que de ahí era donde venían esas señales.
Y debe ser la que están por allá. Porque esto llega hasta 15 metros, ¿no? ¿Te das cuenta? ¿No? Debe ser los que están, son los más cerca, no hay más.
Aún nos quedaban dudas. Por eso fuimos al lugar donde encontraríamos mucha gente, y ese fue la Plaza San Martín de Lima el sábado 27 de noviembre de este año. Nos metimos dentro de un grupo diferente que se manifiesta a favor del presidente Pedro Castillo, y allí aparecieron esas otras señales aparte de los teléfonos celulares. También nos acercamos a la manifestación de los luchadores por la libertad, también llamados antivacunas, donde supuestamente van solo gente sin vacunas. Veamos qué pasó. Nos metimos al medio de este grupo de gente sin inocular y... ¡oh, sorpresa! No había de esas señales. Entonces, no podemos evitar preguntarnos, ¿por qué donde solo hay gente sin vacunar contra el COVID-19 no aparecen tantas señales Bluetooth? ¿Quién autorizó a que conviertan a muchas personas en antenas receptoras de señales Bluetooth?
Un inocuo experimental que lejos de ser eficaz causa daños adversos.
Y por Dios, que alguna autoridad responda. ¿En qué nos están transformando?
joined today by Shimon Yanowitz and Matt Taylor. These two gentlemen have done amazing work researching the nanotechnology inside the COVID-19 injections. But I wanted to go into a deeper discussion today with Shimon and Matt, because the reason these two are unique in their research is Shimon's actually spent time as a scientist and independent researcher, but originally from electrical engineering. Matt has a similar background, which is why we wanted to have a discussion with these two gentlemen about the nanotechnology in particular. So before we get into the findings, Shimon, do you mind just giving the audience a very brief overview of your background? And then we'll do the same with Matt, and then I really want to get into some of these findings.
And so I bring with me the expertise of microscopy, a knowledge of electrical engineering and electromagnetic signals and radiation that Matt here has demonstrated is so relevant in this nanotechnology issue that we are handling. And 3 years ago, even before COVID, I was part of a group, an international group that protested against the unprecedented and scandalous deployment of the 5G global network infrastructure. And then COVID happened, whatever that COVID means. And so it was pretty clear that these things were somehow related. Now, when COVID started, they started talking about the injectables. And even beforehand, we, colleagues and I, have done some research into face masks and swabs, and we found amazing things in there. I think Matt later discovered that Matt has done some work on that too. So when the injectables came out, I immediately set out with colleagues to start finding out what technologies are hiding in them. And that's what we are here to talk about.
And Matt, similarly, your background is in electrical engineering as well, as far as I understand. Talk us through a brief overview of your history and how you came about this, researching this field.
It's absolutely fantastically interesting if it weren't so evil. And I don't want to lose the humanity part of this. We're going to present a lot of technical material, but I definitely want to get that point across, that this is a human disaster that's happening. And I felt, with my background being electrical engineering, I've always been a nerd. I've always been an experimenter. I build stuff and break it and fix it. That's basically my only qualification. But because of that, in heating, ventilating, and air conditioning, electrical power systems, all that stuff, I've always been selected to help lead very highly technical teams. So, for example, when the mask thing came out, I have spent hundreds and hundreds of hours in clean rooms and bio facilities in a mask trying to get equipment to work. So I knew exactly what they were capable and not capable of, dangling preposition, and I started there. And I looked at the mask. I had a microscope because I look at my own compost because I'm a gardener. And I just kept finding stuff, and I haven't stopped. And believe me, I'm a lazy retired engineer. If I didn't find anything, I would stop and not produce anything. But because of the human side of this, which is they are putting these things onto people, they are putting this stuff into people, I'm just compelled. I don't have a choice at this point. I have to say something because of what I know.
Well, I really respect that and appreciate both of you coming on here to discuss your point of view. I think every single conversation that we have around this is vital to understanding what technology has actually been injected into people, billions of people worldwide. And the more we dig, the more we find. So I guess I'm going to open the floor for either you or Shimon, Matt, whoever wants to go first with what you have to bring to us today. Shimon has also found things other than the nanotechnology inside of the injections, working with colleagues across the world. Perhaps we'll start there, Shimon.
Yeah, the main thing is nanotechnology that we found in there. Now, this nanotechnology branches into several aspects. One of them is the electronic circuitry, and another is, there are several what these people like to euphemistically call drug delivery system that can take the shape of tubes, ribbons, or just junk structures that clog the arteries and the capillaries. This is all nanotechnology. What it means basically is when you look at a vial of one of these injectables, you can see clear liquid. There aren't any structures in there. But when we thawed and looked onto freshly sealed and freshly opened and thawed vials under a microscope, we were startled. Things started to self-assemble, as I anticipated, because I was looking into this nanotechnology beforehand, and we knew, because the manufacturers, at least Pfizer and Moderna, the two main ones, and the regulators told us that there should be lipid nanoparticles in them. And the name lipid nanoparticles sounded to me very close to nanotechnology, which indeed it turned out to be.
We've also got, just the other day, yet another announcement of another facility, an mRNA facility here in the state of Queensland, when we've already got two that are planning on producing 400 million doses a year for a population of roughly 26 million.
They might contain genetic material indeed. In fact, some of them do. We know, we tested it. So there is a lot of nanotechnology in there. You have to remember that apart from the main two manufacturers, Pfizer and Moderna, there are other manufacturers which are not said to include mRNA technology, but their injectables are in this as well. We have, for example, Johnson & Johnson and AstraZeneca, and we have the Chinese Sinovac injectable.
So
and
let me just confirm, Shimon, you have found nanotechnology in these other brands as well?
Well, I personally haven't. I have found nanotechnology in the Moderna and Pfizer ones because it turned out to be very complicated to obtain vials from AstraZeneca, sealed or good quality vials from AstraZeneca and Johnson & Johnson, not to mention the Sputnik, the Russian one. And
sure. But have any of your colleagues around the world managed to test those vials?
Yeah, so when colleagues look at those two, or I don't know if they looked at the Russian and the Chinese one, but the other two, the AstraZeneca and Johnson & Johnson, when we look, we see the same nanotechnology developing and creating structures there too.
I'd be extremely interested to know whether the Russian injection and the Chinese injection have this as well. If you can find that out, please let me know. Because I want to know whether these two countries have done it to their people also. Sorry, do go on.
It's not just to their people. They are exporting this stuff also,
yes.
From which electronic circuitry self-assembles and other creatures self-assemble, and there is toxins dispatched into the body, and there's a delayed mechanism, and all this is talking and communicating with electromagnetic radiation. And this is unfortunately a global genocidal and transhumanist operation. So I suspect that behind the scenes, they are all very much coordinated and in this together. And they are deciding where to steer, where to ship which injectable to, and they don't intend to spare a single person or human being, maybe not even an animal on this planet.
All right. Well, I know our time is limited today, so I'd really love to go through some of your presentation. I'd also love to get Matt's take on this, because I want to actually link 5G and what you and your colleagues around the world have found, because they are linked, and people need to know it.
Yeah. So I can start by showing you what comes out of freshly thawed Pfizer and Moderna vials. What I want to show you here is this is a unique opportunity to look at sealed and frozen vials that were freshly thawed. Okay, in all the other cases, we are using used vials because the sealed ones are very hard to come by. So this is, for example, this is from Pfizer and Moderna, and you know the narrative goes that they contain lipid nanoparticles. So much to our surprise, by looking at these, I kept these in image format so I can zoom in and out. We see some huge particles, such as this one, and even the smaller ones you can see here, many particles that shouldn't have been there at all. And this is immediately upon thawing, and you can see right from the start that one of these particles is sprouting something, right?
Right.
So this is the first step of self-assembly that emanates from these large particles. So obviously the contents here is not according to spec. So they lied to us, right? And some of these maybe they are huge micro lipid particles. Some of them are very big indeed. Let's move on. This is very interesting. This is a Moderna sample, and what we did is we looked at some of the large liposomes that I showed in the previous slide, and at room temperature, on the glass slide of the microscope, some of them popped. And when they popped, we could see that they contain further particles and these needles, and indeed the matter that you should see as some grayish yellowish halo. Can you see this?
Yes.
Okay, so this is like a matryoshka kind of packaging. Liposomes within liposomes and other structures and matter. Now this other matter could be the famous hydrogel, which is what they call lipid nanoparticles, or it could be toxins or some liquid, right? So these two popped, A and B, and you can see that they contain further spheres and needles. And I was very interested in the needles because I thought that these were the buds of some nanotechnology that would later grow, and I'll show you what happened. And image C here is after this sample above dried out. So you can see that there are no longer lipid particles. They all popped. What remained is this matter, which could be a hydrogel or some toxin or both, and these needles and some structures that you can see. Here are some needles. Okay, sorry about the resolution here.
That's okay.
And image D shows that some of the liposomes, the bigger ones, these are very big ones, were stable enough and remained stable even when the entire sample dried out. Moving on, we decided to do some more elaborate tests. We prepared some glass slides that could accommodate more liquid and have a reticle for measuring this, and this is what we discovered. So this is a Moderna sample that we put into this chamber that you see here. This chamber here.
That's okay.
And the first thing that you should see is this reticle size is 50 microns. So this liposome here, you can see two things about it. First, it's transparent because underneath it, you can see the reticle line. Whereas this sphere, for example, is not transparent because it obscures the reticle line. But this is some 25 microns in diameter. What the hell is such a large liposome doing in a lipid nanoparticle solution? And you can see that there's some different colors here. This one.
Well, what does it mean that some of them are transparent and some aren't? I don't really understand that.
Well, it means that there are different kinds of them.
Right.
And even the colors here suggest this. This is yellowish.
And do we know what it means that there are different kinds? Does that mean that they potentially are programmed to do different things?
Well, optical microscopy is limited. We don't know exactly what's in them, but we do know that they are not identical. So we do know that this is not according to spec.
Right.
The spec does not specify different kinds of liposomes.
Sure.
And it doesn't speak, again, you can see this matryoshka type thing. This is a bit vague. I'll show you a better image later, but you can see particles within this larger particle and also something budding from it. And the more interesting is what happened when we switched to phase contrast. These are the bluish images. Phase contrast, like dark field, is just another microscopy technique to enhance the contrast, especially of transparent particles. And so this is image C. Is rather benign. You can see what I said earlier, that there seem to be quite a few types of different types of liposomes, and also other structures. And these images are now taken in 5-minute intervals. These are still images, and you can see that 5 minutes. Sorry, this is 5 minutes. 5 minutes into looking at this under the microscope slides, structures begin to develop.
Right.
And these linear structures are obvious self-assembly. And let's go another 5 minutes. Look at the tail, the filament that is emanating from this particular liposome. And we can see another motif that you'll see later, more of it, the string of beads, chain of beads. Here's another one, right? So these things are starting to assemble. And this is at room temperature, just 5 minutes. So obviously people already, the unlucky ones who were injected with this already got injected with nanotechnology that started self-assembling. But this is by no means the end of the self-assembly. Here's after 5 minutes more, you can see again beads, chains of beads, and this ribbon here. All these we can revisit later. Sure. And so some characteristic shapes and filaments, right? So there are quite a few filaments here, and for example, this is a boomerang-like filament. I'll show you better images in the Pfizer one. Sorry, which is this one. Okay, again, this is upon insertion to the chamber, and look at the plethora, how many different liposome species there are in here. You can see this by difference in color and
shape,
size.
yes, and size.
Color basically means different structure, different materials. We may not know what the materials are exactly, but we know that the blue one, sorry, the yellow one, this one, cannot be the same as the dark brown one. Right? It's not the same, and this is absolutely not according to specifications. So these started to look more and more like the death shots that they turned out to be. Here's another one from Pfizer. This time you can see a multi-compartmental liposome. You can see the structures within it, and some of them are starting to bubble out. So this seems like some kind of a delayed mechanism, something that stores matter inside of it and discharges it not all at once. And it could even store matter in binary or different materials and combine them upon discharge. This is very, I would say, terrifying. And here again, the self-assembly. Now you can see some accelerated development with respect to Moderna that we saw earlier. So
I was just
already
about to
after-
ask. So is Pfizer developing quicker? Are these structures developing quicker with Pfizer than Moderna?
Yes, in these particular samples, indeed, this was the case.
Right.
We need to apply some caution. We haven't looked at all the batches of Pfizer and
Of
Moderna.
course.
There is our colleague Sasha Latipova and Craig Prader-Cooper have shown that there is apparently a lot of variability between the batches. But what's interesting here is already after 5 minutes, this is a huge S-shaped filament that is formed here, and it clearly emanates from this part of it, and this part, both emanating from this liposome here. Here again, chain of beads. Here's a crystal that looks very sharp and menacing, and 5 more minutes, and you can see this crystal again, and this S-shaped filament is further bent. Other filaments are forming, and more string of beads.
Mm-hmm.
And this one is an isolation of the 3 motifs we see here. In fact, I have a special image just for that one. Here it is. So one motif is the chain of beads. This is bent type filament that clearly, now this clearly emanates from this parent liposome. This is a linear filament that emanates in both ends of this particular liposome, and this one creates this horseshoe-shaped sphere, and other beads and so on. The interesting thing is this part. Now this is phase contrast. This cannot be seen in normal optical microscopy, but phase contrast is sensitive to some refraction changes in the material. So we know that this is a different material to the rest of the medium, and I think that this is probably a hydrogel cloud. Now hydrogel is the technology that takes the basic lipid nanoparticles and forms clusters out of them, of which this is one cluster. Now, I'm speculating here because optical microscopy cannot resolve lipid nanoparticles. They're too small for the optical resolution. We need a scanning electron or transmission electron microscopy for this. But the optical microscopy can resolve a large cloud of these. And this is what this seems to be. And I'm basing this also on the outstanding images of Dr. David Nixon,
right.
With whose dark field microscope we could see clouds of such hydrogel flowing in and participating in the creation of electronic circuitry.
Do go on, Shimon. I'm just mindful that we have roughly 19 minutes left.
Wow. Okay, so I want to let my colleague Matt leave enough time for him to speak. So again, this is some image enhancement that shows this is the Moderna one. You can see that the same principle, but the scale is a bit smaller in the
Yes.
Moderna. And this is the Pfizer one. Again, this is a simple image enhancement of this scary technology. And this is, again, image enhancement of the species of different huge liposomes that we find in all of this. And then at this point, I had the idea of perhaps we should incubate these things at body temperature, because
Right.
after all, this is at room temperature, and the injectables were intended to be injected to people whose body temperature is 37 degrees. And in this case, we did manage to get, so we have one Moderna sample here, and 4 different Pfizer ones, which in Germany are called BioNTech. And we have a control phosphate buffered saline. This is for control. And we did get one AstraZeneca and one Johnson & Johnson, out of which nothing developed. And this, I'm not counting, these images in my opinion, are not reliable. We are not sure as to the quality of the particular AstraZeneca and Johnson & Johnson. What
Sure.
you can see, though, is that at 4 days body temperature, and this is without experimentation with electromagnetic radiation, that came later after the input from Matt, only by applying elevated temperature, more pronounced self-assembly started to be visible. And again, you can see that these structures, wow, these are very large ones. This is 200 microns. So this particular image here, it's almost 0.5 millimeter from end to end. So this could theoretically be seen with the naked eye, just holding it against some light source.
Wow.
And these are very large.
I think what's astounding is that they're different. Like if I compare you could maybe say the BioNTech 1 and 2 are similar, but if you zoom out a little bit, Shimon, 3 and 4 look like they're forming a completely different structure to the others.
That's right, especially number 4 here. What you can see here is it basically prefers to create needles, right? And additionally, some of these green-looking liposomes look like they haven't assembled into anything. So either they were just duds, or they were missing on some, maybe the booster shot or something to provide them with. I want to show that the Moderna basically has the same type of structure as this. You can see this BioNTech 2 and Moderna, only the scale is different, right? So the scale in Moderna seems smaller. If I were to speculate a little bit, in terms of frequency, smaller size means larger frequency. If this is to be indeed to collaborate with some frequency signal. So let me stop here. I think that this is amazing enough to prove that there is nanotechnology in there. They lied to us. This shouldn't be injected to anybody, right? This is just some kind of scary engineering stuff. Okay, let me stop here. So I leave Matt enough time to.
Thank you, Shimon. And yes, we do want to hear from you, Matt, because I'll just let you know we've got about 14 minutes left here on the clock. And I really do want to hear your take and what you really want people to know about this, because I know you're dedicating basically your entire life to this. So people really need to listen up.
Thank you for that. Yeah, it's not enough time to go through everything I've prepared, so I will on the fly pick and choose here.
We can definitely have you both back. We will. But yes, please go through what you need to go through, Matt, and we definitely at another point we can pick it back up.
Okay, let me start a quick presentation here. Can you see that okay?
Yes.
All right, and so and I'm not bummed out about the limited time whatsoever, but what I'm going to do is present this as if I'm teaching other people how to start this investigation. All of this, I'm looking at everything. So the bottom one here is rainwater. This one is a mask. This one is a bristle swab. And these two are from the shots. And I'm seeing these themes. So as people start to investigate any of this stuff, this is what you're going to see. These are just, I'll show this one. But I don't know why this technological stuff is not being discussed, because they told us they're doing it. And that's a fact. So they come right out and say it. And so I don't know that we have the biological stuff, we have the infrastructure stuff, we have all of the AI already, and that's not weird. But suddenly all this micro stuff starts popping up. So my entire approach to this is, if these horrible people have decided that they're going to put this technology into people, which it looks like, then we start looking for flaws. I'm a forensic engineer. When a $2 million piece of equipment blows up for some, I'm getting what's a modest way to put it? I am getting pissed at people not taking this stuff seriously, because this could be the key to unraveling or at least dismantling some of this plan. And this is way easier than talking about mRNA and genetics and changes within your genome and things like that. as far as I'm concerned, this little part of this big problem is just tech. And anything built can be unbuilt. Anything. So that's my motivation, is to do this. But like this guy, Jornet, which nobody really talks about, he's terahertz frequencies, using it as a communication system within human bodies. That's his specialty. So I don't know how much of this got into the shots and how much didn't, but it's starting to get in there. Too much detail on these, but these are this is an overview of all the structures that just I have found, and other researchers have found as well. But there's rectangles. So this is typically how things start or end up depending on environmental conditions. And you'll see thousands of them, like in the lower right. You'll see a mix of things that look vaguely biological and slightly technical. These ribbons, which Shimon has renewed my interest in these, so I'm looking back at a lot of my older videos to take a look at this stuff. These are a huge part of it, and we don't quite know what yet. But they're in everything.
Is it possible because it's graphene?
It's very possible that it's graphene, and it's, I don't know if, I used to think that this was just delivering materials to the site, but Shimon has opened my eyes, and these do much more than just deliver material.
Like what?
It could be possible cabling in between the microchips. These could be some of the sources for the clotting disorders that we're seeing. These are very, very possibly also an antenna. And I think you're going to start hearing the word antenna over and over and over again. That's a synthetic device. I am convinced, or becoming convinced, that that's also an antenna. I really am. So,
and when you say antenna, are we talking about something that is potentially drawing in more radio frequencies from 5G than others? Are we saying an antenna that can be remotely programmed?
Responsible for a whole, they control a lot of cell functions. So they already behave almost like an antenna. All an antenna does is receive a signal and send one out. That's all it does. So these look more and more like they are giving instructions to the cell that nobody can seem to explain.
I see.
So I think that's a valid path of inquiry. These other outlines, and many, many people have seen this, these usually happen without a dense EMF field. But this is an example of a foundation that starts to get filled in, and these two images on the left show that pretty distinctly. That this upper one turned into this lower one in a matter of maybe 2 hours. But everyone I've shown these to, anyone who has an opinion on the matter says that these look like circuits. And then over here, based on what Shimon and I have been discussing lately, these look like they're hooking up to something. The other thing that we haven't gotten a chance to talk about is the MAC address phenomenon, which is a real thing. I'm investigating that right now. But this is a circuit.
And the fact that people are emitting detectable MAC addresses does suggest that there is some electronic circuitry within them.
Ahora después, justo ahora después, vamos a ver un resumen que ha hecho un enorme científico que vamos a proteger bajo un seudónimo que ustedes conocen muy bien. Y cómo ha identificado todas las imágenes con parámetros de la literatura científica dentro de el análisis que se ha hecho por el doctor Campra dentro de las vacunas. Vamos a verlo. Vamos a compartir pantalla. Muy bien. Bueno, el seudónimo del científico es Mick Andersen y vamos a ver un breve resumen de lo que son las nanorredes intracorporales. Ahora vamos a hablar de nanotecnología, precisamente de lo que se intenta hacer, el futuro o el propósito de esta operación, donde Elon Musk es una pieza importante. Tiene carta libre. Está dentro del objetivo y el plan de la élite. Vamos a empezar. Esquema de la nanored intracorporal. Vamos a ver este dibujito y aquí lo entendemos todo. En este esquema se observa todos los componentes que se introducen en cada o con cada inoculación. En conjunto actúan como una red para la monitorización del cuerpo humano. Y por una parte, como digo, estamos hablando de monitorear, de mapear, ¿eh? Pero lo más preocupante quizás sea, esto ya es preocupante, porque han sido ustedes marcados como ganado, pero lo más preocupante es la neuroestimulación, es decir, recuerde que un router envía señales, pero también recibe señales. En este caso, estos nanorouters enviarán información de las constantes vitales, de actividad cardíaca, de la tensión, del nivel de glucosa en sangre, etcétera. Pero también se le pueden enviar señales. Y como consecuencia del envío de esas señales se pueden producir cambios en la biología o cambios en el nivel conductual si estamos hablando de una nanored intracerebral. En este caso estamos en la intracorporal. En conjunto actúan como una red para la monitorización del cuerpo humano. Estas imágenes que ustedes ven aquí están extraídas por una parte de la literatura científica y comparadas con la vacuna de Pfizer que encontró, o esas imágenes que encontró a la microscopia óptica y electrónica el doctor Campra. Componentes de la nanored intracorporal. Los que han sido identificados son nanotubos de carbono y sus derivados, puntos cuánticos de grafeno, nadadores de hidrogel, nanoantenas fractales de grafeno, nanorouter o nanocontroladores, códec o nanointerfaz, ¿vale? Es decir, codificadores para encriptar la información en la comunicación. Recuerden que estamos hablando de una tecnología que se está descifrando, pero una tecnología militar muy avanzada. Y por supuesto a espaldas de la sociedad civil. De hecho, a espaldas del 80% de la sociedad civil que piensa que esto era una vacuna. Entonces, lo primero, como digo, es resetear toda la información y ofrecer la información correcta, aunque sea dura. La topología de la nanored se nos habla de nanonodos, de nanosensores, nanocontroladores y nanointerfaz.
Folks put inside the slippery particles. They put the mRNA, each in an individual mRNA strand, inside what's called a nanoparticle, which just means really tiny and really slippery. And these really tiny slippery particles can go into the brain, they can cross into the ovary, they can cross through the placenta, into the fetus. They can go anywhere. They can go to the testicles, they can go to the heart, the spleen, the immune system. And they do go everywhere. And here's the number. The number of slippery particles with mRNA spike protein generating crap in them is 40,000 billion. That's how many mRNA blueprints go into everyone's arm every 3 to 6 to 9 months. Thank you, Mr. Trudeau. Every 3 to 6 to 9 months, you want to put in 40,000 billion mRNA messages that will harm your immune system, knock down your T cells, make you look more likely to get cancer, and kill you outright if you're unlucky in the first 6 months. So, I know I'm a bit dramatic at the moment? Why shouldn't I be? These are terribly dramatic numbers. They're unacceptable numbers. And it shows that someone at the top, somewhere in the beginning of this whole mess, had it in for society. Society, stop taking the shots. Judges, stop authorizing mandates in any fashion to continue. Politicians, for God's sake, wake up, be a human being. Protect your own granddaughters, protect your own mothers, protect yourself. Don't take these shots. They are immune damaging. We all know it. 40 trillion every shot, 40,000 billion. 40 times 10 to the 12th, if you're good at your math, boys and girls. That's too many viral particles going into you. Please stop. Thank you.
Intercalated graphite. That's quite a lot, actually. So we started with about 5 milliliters and we exfoliated it into this 750 milliliters. So that's about 150 times volume.
what we've designed, and we've done this very, very quietly, is this idea of Teslaphoresis, which is a discovery we made several years ago, and we've been developing it. The simplest way to understand it is self-assembly at a distance, just long-distance assembly of materials. So we decided to use nanotubes, and what we discovered was that these nanotubes can actually string together and form wires by themselves under this electric field. Realized that a Tesla coil could actually do this if you designed it in a way to create a very strong force field in front of it. And then once I designed the machine, then all sorts of discoveries started falling out of it.
This also ties in just generally in nanotechnology that self-assembly is very big.
It's very much like a web sort of stringing out together. And that was a surprising finding. And the physics of that is actually a lot richer than what we had originally thought.
So there is new science coming out of this as we go.
Vamos a empezar con el análisis de este vídeo y van a entender ustedes muchas cosas. Recuerden la exposición del doctor o catedrático Hermenegildo en la Universidad Hernández de Elche. Entonces hemos hecho unos cortes que son divinos, para entender y asimilar el conocimiento. Vamos a ello. Hay una serie de paradas
de grafeno y aplicaciones.
Hay una serie de paradas en las cuales son necesarias parar, como digo, para comentar todo el material expuesto.
Fundamentalmente lo que hemos trabajado es en otro tipo de aplicaciones, no en biotecnología, y lo que pretendo un poco es, porque este centro justamente sé que está muy especializado en biotecnología, quiero un poco vender el material por si acaso, ver qué se puede hacer con grafeno y qué se está haciendo.
Bueno, lo primero que ha dicho es que este centro está especializado en biotecnología, vamos a decir tecnología aplicada a la vida, y en este sentido utilizando el material en el contexto del grafeno. Seguimos.
Donde vemos el grafeno es como si fuera un velo que dejado caer sobre una superficie no se queda completamente liso, sino que muestra las arrugas típicas del grafeno.
Las arrugas típicas del grafeno, los famosos pliegues que hacen tan característico al material. Pliegues que son característicos desde el punto de vista óptico, desde la microscopía óptica, y pliegues, ese velo que también era muy característico en las imágenes obtenidas por el doctor Campra en el informe preliminar a la microscopía electrónica de transmisión.
Por la flexibilidad.
¿Vale?
Y además estas propiedades que lo hacen muy adecuado para microelectrónica y también para aplicaciones en biotecnología.
Y muy adecuado para aplicaciones de microelectrónica y aplicaciones de biotecnología. Microelectrónica, pues electrónica a nivel micro o incluso nano.
La respuesta, de hecho, en muchas aplicaciones optoelectrónicas en telecomunicaciones, por eso...
En telecomunicaciones, cuando habla de aplicaciones optoelectrónicas se refiere a interacción con campos electromagnéticos, por ejemplo, microondas.
Porque podemos mandar ondas de frecuencia muy rápida en terahertz basados...
Podemos mandar ondas de frecuencia muy rápidas o de radiofrecuencias en terahercios. ¿Qué es lo que hace el grafeno sino convertir los gigahercios en terahercios? ¿Cuántos artículos científicos hemos visto de micro y nanotecnología intracorporal en la banda de terahercios? ¿Cuántas patentes hemos visto, incluidas algunas de José Miguel Jornet, este natural de Tarragona, de la Universidad Politécnica de Barcelona, donde hablaba de nanotransceptores basados en grafeno en comunicación en la banda de terahercios, o antenas plasmónicas basadas en grafeno en la comunicación de terahercios.
En grafeno. Cuando uno quiere hacer microelectrónica, algo muy pequeño, pues el grafeno es adecuado.
Efectivamente, el grafeno es adecuado para la microelectrónica. En principio, algunos de ustedes estarán pensando también en aplicaciones industriales, ¿verdad? Desde el punto de vista comercial industrial de circuitos de microelectrónica. Pero también recuerden, en el contexto de la biomedicina, biotecnología.
Por ejemplo, el grafeno es casi completamente transparente.
Aquí es muy importante que me pare, porque el señor Diego Peña, catedrático del CICUS, de la Universidad de Santiago de Compostela, nos decía que el grafeno era negro, y que poco más, que no servía para gran cosa. cuando incluso precisamente recuerden que Diego Peña fue entrevistado precisamente por la doctora Albarracín, que es sospechoso, y publicado precisamente en la plataforma de periodistas Por la Verdad.
El ojo no lo ve cuando tiene una monocapa, pero tan pronto como hay dos capas, de una a dos capas, entonces el ojo, esto es este eje vertical, es cómo la luz se transmite, y esta es la longitud de onda, esta es la zona del visible, y este número de aquí, casi 100%, significa que transmite toda la luz atraviesa el grafeno, de hecho con una monocapa el ojo no la ve. Pero
con una monocapa el ojo no la ve porque es translúcido un 98,75%. Es prácticamente transparente. Pero conforme se van adicionando capas, ya empieza a generar determinado nivel de opacidad. Es decir, con dos capas ya tenemos cierto nivel de más opacidad, como digo, y ya el ojo puede percibirlo. El ojo a través de un microscopio óptico al menos.
Nada más tiene dos capas, la transmitancia baja y ya se pone en 90 y algo %, porque una capa...
Se pone exactamente en 98,75 por 98,75, que da un 95% de translucidez y un 5% de opacidad. Por lo tanto, ya el ojo puede distinguirlo.
Hay otra forma de interacciones pi-pi, de stacking, y eso hace que puedan absorber los fotones, porque hay transiciones electrónicas nuevas, y entonces el ojo empieza a ver, como se ve aquí en la imagen, algo gris. Hay algo ahí. De manera que solamente con dos capas que no llegan a un nanómetro de espesor, el ojo, que aquí hay gente especializada en ojo, ya es capaz de ver dos capas de grafeno que tienen un espesor de menos de un nanómetro, simplemente por el color que se desarrolla.
Importante, característico.
Los materiales son constitutivos del carbono. Ahora, el día 14 de marzo acaba una convocatoria europea, donde hay dinero. Sabes que nosotros siempre los científicos necesitamos dinero para investigar.
Eso es importante. Lo que has dicho, nosotros siempre, los científicos, necesitamos dinero para investigar. Está hablando un poco de la financiación, o como aquí decimos, de la prostitución. Cuando habla del 14 de marzo, ahora, se refiere al 2017, cuando se emitió esta conferencia.
Hay dinero, ahí vamos.
Efectivamente. Donde hay dinero,
la misma electrónica que hemos hecho con silicio, con el carbono. Pero ¿qué ventajas tiene? Que será mucho más barata, mucho más rápida, mucho más pequeña, mucho más eficiente, o sea, todo mucho más. Con lo cual, aquí claramente hay mucho futuro. En óptica,
aplicaciones ópticas, hace referencia, como digo, a la comunicación, telecomunicaciones.
Bueno, pues hemos dicho que justamente como es transparente y es conductor, tiene muchas propiedades optoelectrónicas, mucha respuesta electrónica.
Perfecto.
Este seguramente será el material más destacable de todo el siglo.
Y esto es tan destacable que lo están introduciendo dentro de la biología humana. Incluso, y esta parte no la he puesto, habla de las famosas edades. La edad de bronce, cuando se introdujo el bronce, la edad de hierro, y ahora viene la edad del grafeno, con el famoso hexágono que está copando incluso los telediarios, como ustedes saben.
Bueno, la exfoliación
del material.
De otra manera, para indicar que al haber hecho un tratamiento químico, la calidad del grafeno no es tan buena, la conductividad electrónica no es tan buena, tiene imperfecciones, tiene defectos, que eso no tiene por qué ser malo. Las arrugas no tienen por qué ser feas, pueden ser bellas, pues aquí igual.
Está haciendo referencia precisamente a las arrugas, a los pliegues característicos del material como imperfecciones. Que está hablando de un proceso a través del grafito, como una forma de carbono, para llegar a un derivado del grafeno, pasando por el óxido de grafeno y obteniendo óxido de grafeno reducido, que es precisamente el que obtuvo el doctor Campra en los inyectables de Pfizer, AstraZeneca, Moderna y Janssen, y también se obtuvieron en Reino Unido.
En cierta medida lo conseguimos, pero hay imperfecciones, de manera que este material que aparece aquí ya no tiene exactamente ese nombre de grafeno, tiene un nombre que es óxido de grafeno reconstituido o reducido, y siempre le queda algún oxígeno alrededor, incluso algún defecto y tal. Pero ya digo que hemos investigado mucho en este tipo de materiales y los defectos son muy útiles para algunas aplicaciones. Bueno, cuando hablamos del grafeno, voy a comentarlo rápidamente, en muchas formas de caracterización, pero
atención, que esto es importante.
Una que es imprescindible es el Raman.
Una que es imprescindible es el Raman. A la hora de caracterizar el grafeno, ¿por qué? Porque tienes el diseño estructural, que ya es característico desde el punto de vista óptico, y los picos característicos del material, que te lo va a dar, como digo, la espectroscopía Raman. Por lo tanto, la técnica micro-Raman asocia el objeto de apariencia grafénica con los picos característicos del material. Por lo tanto, no hay duda o inequívocamente concluyente, como dijo el doctor Campra, se debía o se encontró óxido de grafeno reducido.
El Raman es como si lo hubieran hecho solamente para ver el grafeno.
Vaya, el Raman o la espectroscopía Raman, que consiste en ese barrido de láser, es como si lo hubieran hecho sobre todo para ver el grafeno. Lo digo porque como hay gente aparentemente científicos, sobre todo de la falsa disidencia, que decía que hacían falta más técnicas, que eso no... Pero no solo con la Raman. Este hombre incluso reconoce que a través de la microscopía óptica ya es caracterizable el material. Vamos a verlo.
Bueno, nuestra aportación fue esto.
Esto es importante, atención.
A partir de gambas, primero te las comes y disfrutas, pero luego la piel, economía circular, hay que utilizar todos los residuos. Pues tenemos ya la piel. Y resulta que la piel tiene un componente, la piel de todos los crustáceos, que es la quitina. De la quitina se obtiene el quitosan.
De la piel de todos los crustáceos, pero también de los insectos, lo va a decir después, se obtiene el quitosan. Se obtiene la quitina, que es un precursor del quitosan.
Y ese es el precursor para conseguir el grafeno.
Y el quitosan es el precursor para conseguir el grafeno. Atención, porque después vamos a unir todo esto y van a entender ustedes por qué quieren que nos alimentemos con insectos y con algas.
Bueno, pues nuestra aportación aquí fue esto, que este carbono, que eso ya era conocido, que los carbohidratos pirolizan y dan carbono, pues esto con ultrasonidos se exfolia.
Con ultrasonidos, algo de lo que también somos conscientes que han bombardeado a la población.
Y al exfoliarse, lo que da es grafeno.
Vale, muy bien.
No todos sirven para dar grafeno, nos hemos dado cuenta de cuáles. Son biopolímeros de desecho, pero aquí la palabra aparece filmogénico. ¿Filmogénico qué significa? Que sean polímeros que sean capaces de formar películas. Y eso la naturaleza lo sabe. Y por eso eligió para la piel de gamba, ese polímero.
Pero también para las algas, el alginate, otro, ¿de acuerdo?
Por eso eligió para la alga ese polímero, porque entonces con ese polímero forma la piel de la gamba sin ninguna rugosidad, forma la piel de insectos, de crustáceos,
forma la piel de insectos, de crustáceos, insectos, porque claro, en principio no te van a decir que te comas la cáscara de la gamba, pero insectos sí que nos están proponiendo alimentarnos con insectos. Y en la piel de los insectos, o lo que forma parte del exoesqueleto, está presente la quitina, que por cierto es tóxica para el ser humano. Y de la quitina se extrae el chitosan. Y el chitosan es precursor del grafeno. Seguimos.
La naturaleza, muchos años de evolución, muchos siglos de evolución, eligió este. Bueno, pues una de las gracias es que los polímeros naturales a veces tienen heteroátomos. Por ejemplo, el quitosan tiene ciertos átomos de nitrógeno. Tiene, de hecho, un 15% de nitrógeno en su composición, ese polímero. Pues cuando yo lo pirolizo, lo pongo a temperatura muy alta, me forma un grafeno. Forma un grafeno, pero un grafeno que se dice dopado.
Un grafeno dopado.
El que sabe electrónica siempre quiere silicio dopado. Para electrónica es súper importante porque formamos un grafeno que está dopado de quitosan que está hecha de una manera y con...
Recuerden que cuando hablamos del quitosan, ustedes tengan presente el exoesqueleto de los insectos, de artrópodos, de estos gusanos de piel dura, de grillos, de saltamontes, etcétera. De lo que se pretende introducir en el ganado humano, como ellos nos llaman, como nueva cadena alimentaria.
Esta capa es mucho más fina, hemos hecho un corte con un cúter para ver cuál es el espesor, y el espesor, según la AFM, son 23 nanómetros. Pues esta, cuando se piroliza, pues lo que da al final es un grafeno de 4 capas.
Un grafeno de 4 capas, es decir, de considerable pureza y calidad.
Si ahora estos films tú los pirolizas, te da una película de grafeno. Esta es una imagen de microscopio.
Pirolizarlo es prácticamente meterle fuego. Bueno, vamos a parar aquí el documental, estamos en el minuto 6:20, porque ha hablado del quitosan, ha hablado de la quitina, y que del quitosán fácilmente vamos a tener grafeno de gran pureza, de 4 monocapas, ha dicho, de 23 nanómetros de espesor, considerable, ¿verdad? Pero claro, evidentemente, si nos ponemos a extraer el grafeno del quitosán que está presente en las capas del exoesqueleto de los insectos, pues es algo caro. A no ser que haya empresas comercializadoras de insectos para el consumo humano. ¿Entienden? ¿Por qué? Pues porque si hay empresas que comercializan e introducen, fomentado, como siempre, como no, por el Foro Económico Mundial y de su Agenda 2030, pero claro, evidentemente, si nos ponemos a extraer el grafeno del quitosán que está presente en las capas del exoesqueleto de los insectos, pues es algo caro. A no ser que haya empresas comercializadoras de insectos para el consumo humano. ¿Entienden? ¿Por qué? Pues porque si hay empresas que comercializan e introducen, fomentado, como siempre, como no, por el Foro Económico Mundial y de su Agenda 2030, y que introducen, como digo, para la alimentación humana el consumo de insectos y de algas, pues evidentemente todo eso va a abaratar los costes de...
centre nerveux humain. Et c'est là que la récente décision de la Commission européenne de développer l'alimentation par insectes de la population européenne, d'autoriser l'intégration d'éléments d'insectes dans un certain nombre d'aliments vendus sur le marché pose problème. Pourquoi? Parce que la nourriture des insectes, au terme notamment d'un brevet déposé par la Chine, est en partie composée d'oxyde de graphène. Parce que cet oxyde de graphène, déjà présent dans les vaccins à ARN messager largement distribués à l'occasion du Covid, cet oxyde de graphène a des particularités tout à fait particulières. D'abord, c'est un oxydant puissant. Et on sait qu'un oxydant puissant est dangereux pour la santé humaine. Ensuite, c'est une molécule qui présente des particularités tout à fait spécifiques dans certaines conditions, et notamment dans des conditions qui sont celles de la température du corps humain. Elle peut se grouper en macromolécules avec des propriétés de sensibilité aux radiations tout à fait particulières. Ce qui donne le scénario de l'apocalypse suivant. Les nanoparticules d'oxyde de graphène se regroupent dans le corps humain, notamment à proximité des centres nerveux, le cerveau, le cœur, les viscères. Ces nanoparticules peuvent être sensibles à des radiations qui viennent par exemple d'un pacemaker, mais qui viennent aussi des ondes millimétriques qui correspondent à la 5G. Et le scénario de l'apocalypse se dessine, attesté par un certain nombre de publications scientifiques. Si certains voulaient pouvoir créer des états de conscience, si certains pouvaient influer sur le métabolisme humain, mais aussi sur les représentations et sur les connexions nerveuses du corps humain, l'oxyde de graphène leur fournirait une voie royale. Ce n'est pas 1984 et George Orwell qui se profilent, mais nous ne savons encore rien du capitalisme cognitif et du capitalisme qui vise à contrôler les états de conscience d'une population. Au moment où toute l'attention se porte sur la guerre provoquée par l'invasion russe de l'Ukraine, nous ferions bien de nous intéresser aussi à